At 2:47 p.m. on August 16, 1934, the massive construction site of Hoover Dam fell silent for the first time in 3 years. Not because of a strike, not because of an accident involving human life, but because 42 tons of Caterpillar D8 Bulldozer had just disappeared into wet concrete and nobody knew what to do about it. The temperature at Black Canyon that afternoon reached 119 degrees Fahrenheit. Frank Crowe, the dam's chief construction engineer, stood on the Nevada rim watching his crews work 400 feet below. Crowe had built more dams than any man alive. He'd pioneered the use of heavy equipment in dam construction, and now one of his prize machines was sinking into column 47 of the dam's foundation like a stone dropped in water. The D8 weighed 84,000 pounds fully loaded. It had been grading the surface of freshly poured concrete when the operator, a man named Oliver Cowan, felt the ground shift beneath him. He'd been working concrete pours for 18 months. He knew what solid felt like. This wasn't it. Cowan had maybe 3 seconds to react. The concrete beneath the D8's tracks was supposed to have set for 6 hours minimum before any equipment crossed it. Someone had miscalculated or misread the pour schedule, or simply forgotten to mark the section as off-limits. The reason didn't matter now. The dozer's left track broke through the crust and the entire machine tilted 15 degrees. Cowan jumped. The D8 kept going. The machine pitched forward, diesel engine still running, and its blade bit into the concrete like a ship's prow cutting through ice. Then it nosed down. The rear tracks lifted. For a moment, witnesses would later describe it as strangely graceful. The 42-ton bulldozer stood on its nose at a 45-degree angle. Then gravity won. The D8 slid forward and down into the wet concrete mixture, disappearing up to its cab in gray slurry. The engine died. Bubbles rose. Then nothing. 18 minutes. That's how long Hoover Dam construction stopped completely while engineers and foremen stood around column 47 arguing about what to do. 18 minutes doesn't sound like much, but this was a project that operated on a budget of dollars per second. 6 companies, the consortium building the dam, had bid $48,990,955 for the contract. They'd calculated every hour, every material ton, every equipment movement down to the minute. The penalty for delays was $3,000 per day. 18 minutes of total shutdown represented a financial hemorrhage nobody had planned for. But it wasn't really about money. It was about the fact that wet concrete, once poured, becomes a chemical reaction that cannot be stopped. The mixture in column 47 contained 1,132 cubic yards of carefully formulated Portland cement, aggregate, and water. It had been mixed to precise specifications. Temperature controlled, aggregate size to 1.5-inch maximum. Water-cement ratio calculated to produce 3,000 pounds per square inch compressive strength after 28 days of curing. And now a bulldozer was embedded in it. If you want to see how Frank Crowe solved an engineering crisis that threatened to compromise the entire dam's structural integrity, please hit that like button. It helps us share more forgotten stories like this. Subscribe if you haven't already. Back to that concrete. Crowe reached the site 7 minutes after the D8 went under. He was 52 years old, 5 feet 10 inches, and weighed 160 pounds. People said he moved like electricity, always 3 steps ahead of everyone else. He'd built the Teton Dam, the Arrowrock Dam, the Deadwood Dam. He understood concrete the way pilots understand air, and he knew immediately that pulling the dozer out was impossible. The problem was chemistry. Concrete doesn't dry, it cures. The cement particles hydrate, forming calcium silicate hydrate crystals that lock aggregate particles in a stone matrix. This process generates heat. In massive pours like dam construction, that heat becomes a serious engineering challenge. Too much heat too fast creates thermal cracking that can destroy structural integrity. That's why Hoover's concrete contained embedded cooling pipes carrying refrigerated water at 40 degrees Fahrenheit. The D8, sitting in column 47, had just become a 42-ton inclusion in that chemical reaction. An inclusion with sharp edges, hollow spaces, and entirely wrong material properties. Concrete is designed to be homogeneous, The D8 was anything but. Its steel components would expand and contract at different rates than the surrounding concrete. Its hollow engine block and transmission housing would create voids. Its rubber tracks and seats would decompose over time, leaving cavities. Worse, the disruption of pulling it out would create massive voids and disturbed zones that could never be properly refilled or revibrated. You can't just pour more concrete into concrete that's already setting. The new and old won't bond. You get a cold joint, a plane of weakness where the structure can fail. Crowe made his decision in under 2 minutes. Leave it. The argument started immediately. Bureau of Reclamation inspectors said the column had to be demolished and repoured. 6 companies' foremen said that would put the project 3 weeks behind schedule and cost $200,000 minimum. Union stewards wanted guarantees that no workers would be endangered by structural weakness. Crowe listened to all of them and then gave his orders. Cover it. Bury it. Build over it. His reasoning was ruthlessly practical. Column 47 sat in the dam's inner core, not its face. It would never be exposed to water pressure. The D8's mass represented less than 4% of the column's total concrete volume. Steel bulldozers had comparable compressive strength to cured concrete, both around 3,000 to 4,000 psi. The main structural concern was the voids, and voids could be addressed. Crowe had his crews continue pouring concrete over the partially submerged D8. They worked in 8-foot lifts, the standard pour height for the dam. But instead of the normal aggregate mix, Crowe ordered a modified grout mixture for the immediate area around the dozer. Higher cement content, smaller aggregate, more water, the consistency of thick soup. It would flow into every gap, every hollow, every space around the bulldozer's frame. The pour took 6 hours. They used 340 additional cubic yards of concrete. The D8 disappeared completely beneath the gray surface. By 9:15 p.m., column 47 looked like every other foundation column in the dam. Nobody watching the next morning's shift would have known anything unusual had happened. But Crowe wasn't finished. He ordered core samples drilled through the area where the D8 sat. 3-inch diameter cores pulled from depths of 8, 12, and 16 feet. The lab technicians tested them for voids, cracks, and bond quality. The results came back acceptable. Not perfect, acceptable. The modified grout had done its job. The concrete around the bulldozer had cured without major defects. Still, Crowe added redundancy. He had engineers recalculate the stress loads for that section of the dam, factoring in the D8 as a permanent inclusion. They adjusted the placement of reinforcing steel in adjacent columns. They increased the concrete strength specification for the next 3 lifts above column 47 from 3,000 psi to 3,500 psi. They added extra cooling pipes to manage heat generation. The total cost of these modifications, $41,000. The cost of demolishing and repouring the column, $200,000 minimum, plus 3 weeks of schedule delay. Crowe's solution saved 6 companies $159,000 in 18 days. The board of directors sent him a letter of commendation. The Bureau of Reclamation sent an inspector to verify structural integrity. The inspector spent 2 days taking measurements, reviewing calculations, and examining core samples. He signed off on the work. The D8 stayed buried. Oliver Cowan, the operator who jumped clear, went back to work the next day. He was assigned to a different section of the dam. Nobody blamed him. The accident investigation determined the pour schedule had been incorrectly marked. The foreman responsible was transferred to a different project. The scheduling system was revised. Additional safety protocols were implemented for equipment operation near fresh concrete. But here's what makes this story worth remembering. That bulldozer is still there. Column 47 is now approximately 300 feet below the dam's crest and 200 feet behind its downstream face. It's encased in 3.25 million cubic yards of concrete. It's held the weight of 9 trillion gallons of water for 90 years. It's survived earthquakes, floods, and the thermal expansion and contraction of the entire dam structure through summer temperatures exceeding 120 degrees and winter temperatures below freezing. In 1948, when the Bureau of Reclamation conducted a comprehensive structural survey of the dam, they drilled investigative cores through the area where records showed the D8 was buried. The cores showed no cracks, no voids, no structural anomalies. The concrete surrounding the bulldozer had cured to full strength. The modified grout technique Crowe had improvised in 18 minutes had worked exactly as he'd calculated it would. The D8 incident became a teaching case at engineering schools, not as a cautionary tale about what not to do, but as an example of crisis decision-making under pressure. Crowe had faced a choice: follow conventional wisdom and demolish the column, or trust his understanding of concrete chemistry and leave the inclusion in place. He chose based on engineering principles, not fear of criticism, and he was right. That's the part of the story that often gets lost. The 18 minutes weren't wasted time. They were thinking time, calculation time, decision time. Crowe could have ordered immediate demolition. He could have panicked. He could have deferred to committee. Instead, he stood at the edge of column 47, looked at 42 tons of submerged bulldozer, and worked the math in his head. Concrete chemistry, structural loads, thermal expansion, bond strength, risk assessment, 18 minutes to make a decision that's held for 90 years. The Hoover Dam was completed in 1936, 2 years ahead of schedule. It cost $49 million, just over budget by 0.02%. Remarkable for a project of that scale. It has generated over 130 billion kilowatt hours of electricity. It supplies water to 25 million people. It has never experienced a structural failure. And 42 tons of 1934 Caterpillar D8 bulldozer sit in its foundation, a testament to the fact that engineering isn't about perfection. It's about solving problems with the information and materials at hand. Frank Crowe didn't have computer modeling. He didn't have finite element analysis. He had 18 minutes, a thorough understanding of concrete, and the confidence to trust his calculations. The D8 is still there. Column 47 is still standing. The dam is still holding back the Colorado River. And somewhere in the archives, there's a maintenance log from 1948 noting that core sample 47A showed embedded ferrous inclusion, no structural impact. That's engineering language for "we found the bulldozer and everything's fine." If this story made you think about problem solving differently, please hit that like button and subscribe. Your support helps us preserve these engineering histories. Tell us in the comments where you're watching from and whether you've ever visited Hoover Dam. Thanks for watching.